Okay, so when we have to work with slope-intercept form, sometimes it's not in that form to start. So in this lesson, we will learn how to answer the question like this one below. It says, what equation of the graph is shown to the right? And it gives us 4 different choices, or actually 3 different equations, but neither of them are in slope-intercept form, okay? So it is difficult to tell what the graphs of the equations will look like above. To learn how to answer this question, we are going to look at some equations that are not in slope-intercept form. And we are going to rewrite the equations below in slope-intercept form and then graph them on the same line. Okay, on the same coordinate plane. So sometimes things are just not in the same order. Okay, so on this first one, if you don't have to move anything, like if you've got y alone, that's a good sign. But you do want slope-intercept form to be y equals mx plus b. So we want this term first. Notice I included the plus in front of it. Okay, so what we're going to do is we're just going to write it y equals 1/3 x. And then the other term that we have is 2. So if the terms get to stay on the same side of the equation, you can rearrange them as long as you take the sign with it. So 2 is a positive 2, so I'm just going to write plus 2. The positive, negative value of those did not change because they did not cross over to the other side of the equation. So they're still just like that. I just rearranged them. So we can do the same thing on the second one. The x is just a positive x, and then the 3 is a minus 3. So I'm going to rearrange these. I'm just going to write x is just positive, but then when I write the minus 3, I have to write minus 3. They didn't change sides, so the sign has to stay with them. The third one, it's a negative 2x. The negative has to go with that term. Then a positive 4. So it reads y equals negative 2x. And then because it's a positive 4, it just reads plus 4. Now the last one is a tiny bit tricky. And the reason that it's tricky is because the y is not alone. Do you notice that? That the y has a friend over there with him. And the rule is that the y has to be completely alone. So I have drawn a dotted line through my equation. And I have to figure out how to get this 1 away from the y. So in our experience with solving equations, how do we move or cancel out a number? Minus. Yes. So what we are going to do is we are going to minus 1 from both sides of the equation. So when I want to move it, I have to add or subtract it. So this is going to cancel this out, and I'm going to bring down the y that I have left, because a positive 1 minus 1 is 0. Now, I cannot take 1 away from negative 3/4 x because this guy has an x and the 1 does not. So I simply rewrite my expression, my equation, negative 3/4 x minus 1. And that is my answer. Okay, so we're going to graph these lines. Let's see if I have enough colors. Okay, the first one, I'm going to start at positive 2. And it's a third slope, so up 1 over 3, up 1, right 3. 1, 2, 3. Okay, my next one, it starts at negative 3, so 1, 2, 3. And remember, if there's nothing with the x, there's a 1 there. So my slope is up 1, right 1, up 1, right 1. Okay, my third one, I start at positive 4. So 1, 2, 3, 4. And I go down 2 over 1. So 1, 2, right 1. 1, 2, right 1. Okay. My last one starts at negative 1. And it goes down 3, right 4. 1, 2, 3, 1, 2, 3.
Emma Mel to the office.
Okay, so just kind of a little recap from earlier. Okay, so we're going to take this a step further, and we are going to practice getting y alone in all 4 of these next ones. So we can see both sides of the equation. Your job is to move whatever is not the y. So I'm going to just use a highlighter here. So I need to cancel out the negative 2x. I need to cancel out the 3. I need to cancel out the negative 2/3 x. And then on the last one, I just need to move the 2. So anytime you need to move the entire term, you need to add or subtract. Okay, so I don't know if it's helpful for you guys, but maybe that would be a good little note to put on here. If you need to move the entire term, you must add or subtract. Sometimes those little notes are helpful to us. If you need to move the entire term, you must add or subtract. And basically a term is anything between, you know, like a addition symbol or subtraction symbol, that type of thing. So for example, on the first one, do I need to move the entire 2x term? Yes, I don't want to split them up. I want to move that whole thing over. So I need, it's a minus 2x. So what I need to do is I need to add 2x. Whatever you do to that side, you have to do to the other side. Then those cancel out and you bring down the y. Okay, now here's the thing. We know that we need to have the x term first. So I just write it first. It's a positive 2x, and then the 7 is also positive. So this turns out to be plus 7. So y equals 2x plus 7. On the next one, I want to move that entire 3 to the other side. So because it's a positive 3, I need to subtract it. That cancels these out. And I'm left with y equals 1/5 x minus 3. On the third one, I need to move this entire term to the other side. I want to take the x and the 2/3. It is a minus 2/3 or a negative 2/3, so I need to add it to both sides. When you add it to the other side, that creates a positive. So this y comes down. That means my 2/3 is positive. My 5, though, is negative. So I write 2/3 x minus 5. It's all about keeping that positive or negative with the term. Now the last one here is a tiny bit different. We want the y to stay, but the 2 to go. We want to split them up. Anytime you do that, you are going to divide. The only rule is that if you divide one thing by the 2, you've got to divide everything by 2. So what happens here, 4 divided by 2 is 2, and 6 divided by 2 is 3. It just simplifies. Okay. So it says sometimes this takes multiple steps. So I'm still going to go through. I'm just going to do my little scene. Okay. So the first thing you want to do is locate your variable. And then we're going to try to move everyone else away. So we want y alone on all of these. So I'm kind of, some of these are going to get a little crazy. Okay. So on the first one, I need to move my 3x to the other side first, and then I'm going to divide. You always move whoever's furthest away from the variable. So I'm going to minus 3x. And I end up with 4y equals negative 3x plus 8. So we were practicing that on the other side. Then in order to split up the 4 and the y, you need to divide by the 4. And when you divide, you've got to divide everything. So y equals negative 3/4 x plus 2. And that's your answer. The next one, if I have a negative x, how would I move it to the other side? Yeah, we're going to add it. Yep, it's okay, you got the right idea. So then those cancel, you end up with 7y equals just a positive x. And sometimes it's helpful to put a 1 there, okay? Doesn't hurt anything, kind of makes it more clear. And then our next part is to split up the y and the 7, which we're going to do by division. So we divide everything by a 7. We end up with y equals 1/7 x, and that's okay to leave it in a fraction. We like that. And then 21 divided by 7 is 3. This one here, we're going to subtract 8 from both sides first. We have negative 2y equals 5x minus 8. And then don't forget, when we divide on this one, we've got to divide by that negative. It's got a suitcase with it. We got to take them with them. So this ends up with a y equals 5/2. We're just going to keep it as a fraction. We're okay with that. Negative 8 divided by negative 2 equals a positive 4. Okay, last couple, they look harder, but they're really not that bad, okay? Your first step on these ones is to distribute to get rid of the parentheses. You guys have done this. -4 times y is -4y. -4 times a +1 is a -4. 6 times x is 6x. 6 times a -4 is -24. Now it looks like what we were doing before. The first thing that I can do is I can add that 4 to the other side because I want to get the y by itself. Now this time I do have something to add the 4 to because 24 or -24 and 4 can go together. So -24 and a +4 is going to give you a -20. Remember, you can use calculators if you're uncomfortable with that. And then to get y by itself, I'm going to divide by a -4. Get y equals, I take this right away, 6/4. I know that reduces to -3/2. If you don't reduce it right away, just make sure you do eventually. -20, -4 is going to give me a +5. On this one, we need to distribute the 4 on the right side. So it's going to give us x minus y equals 4x minus 12. And then I'm going to subtract my x. I do have an x on the other side to take it away from. So 4x minus 1x, 3x. The last little step on this one that gets tricky is that there's a negative with our y. Remember, if there's no number, there's a -1 there. So you can divide everything by a -1. Three divided by a -1 is a -3. -12 divided by a -1 is a +12. So this one actually comes out very nice. Okay. Last little thing, it says while we're on the topic of weird looking linear equations, let's discover the shape of a couple others. So graph the linear equations by filling in the tables. Now really quick, if you have a y equals 3, what that means is that every y is 3. If you have an x equals something, that means that every x is, in this case, -2. So when you go over to make your graph, it's -2, +3, -1, +3, 0, +3, 1, +3, 2, +3. So your graph crosses the y-axis at +3. So the little catch here is that if it says y equals 3, it crosses the y-axis at 3. Then the other one, your x is a -2, your y is a -2. Your x is a -2, your y is a -1, and so on and so forth. This is a vertical line crossing at x equals -2. So this one is x equals -2, and the other one was y equals 3. So it makes those graphs easy to graph if you can remember that x is going to cross the x-axis and y is going to cross the y-axis. So up here it says, so if c represents any constant, the graph of y equals c produces a, so if it crosses the y-axis, it's going to be a horizontal line. And the graph of x equals c produces a vertical line. So it says graph the equations below on the same coordinate plane. So we've got x equals 4. That means it crosses the x-axis, 1, 2, 3, 4, at positive 4. It says x equals 4. Then we've got y equals 2. So it's going to cross the y-axis at positive 2. That's y equals 2. X equals 0. It's going to be vertical. It's going to go right along our axis here. So this is x equals 0. Y equals -1. It crosses the y-axis at -1. X equals -3, crosses the x-axis, 1, 2, 3, at -3. So this is x equals -3. Last one is y equals 0. That's a horizontal line crossing the y-axis at 0. Okay, so to tie this up, it brings us back to the original problem. We want to know which one of these matches our graph. Okay, so the first thing is, can you get the graph of this equation by looking at the graph, or the equation of the graph by looking at it?
Yeah.
Yeah, so what's our m and what's our b? Our b is +2, and what's our m? Looks like 2/3 maybe, -2/3. Okay, so we know our equation should read y equals -2/3 x plus 2. We've got to figure out which one of these is going to meet that. Okay, so let's real quick just solve for y. So the first one, what would I do to get the y started, to get the y alone? Any ideas? Minus the 2x. So 3y equals -2x plus 6. How do you separate the 3 and the y? Yep, we're going to divide everything by 3. So I get -2/3 x plus 2. Well, that one matches, right? Okay. Okay, the middle one looks the most complicated. We've got to distribute on that one. So I'm going to do that first. 3 times y is 3y. 3 times -4 is -12. -2 times x is -2x. And -2 times +3 is -6. Okay, I want the y by itself, so the first thing I have to do is add the 12. I can add it to the 6. Those cancel. I end up with 3y equals -2x. A -6 and a +12 is going to give you a +6. The last step is to divide by that 3. My y equals -2/3 x plus 2. What do you guys notice?
They're all gonna equal.
They're just going to be the same, maybe. Okay, last one. I want the y by itself, so I'm going to move the 12 to the other side first. I'm going to minus the 12, so I get 4x minus 12 equals -6y. To get the y alone, I divide everything by -6. So even though I'm working on the other side of the equation, it doesn't change anything. We can do that. Okay, -4/6 reduces to -2/3. -12 divided by -6 is a +2. And then remember, you can flip these completely around as long as you don't change anything. So if we did everything correct, every single equation of those three represents that line. And that's where linear algebra gets kind of tricky, because the equations can look so different from each other, but equal the exact same thing.